These are the 6 types of triangles, and in the next few minutes I'm going to show you how to easily and correctly determine the type of any triangle. Keep watching this video to the end and you will never have a problem with the classification of triangles again. Triangles are classified in 2 ways, by side length and by angle measure. Let's first take a look at the types of triangles based on side length. The most straightforward type of triangle is the equilateral triangle. An equilateral triangle has 3 equal sides. The triangle ABC, for instance, has 3 sides, and they're all 3 inches long. That tells us that ABC is an equilateral triangle. Here is another example. Each side of the triangle DEF is 10 centimeters. The sides are all equal, so DEF is also an equilateral triangle. Now, let's do an example question to better understand equilateral triangles. Which of the triangles below is an equilateral triangle? Can you find it? Let's try it together. The triangle ABC we see here has sides measuring 2 feet, 3 feet, and 4 feet. Each one of its sides has a different length, so ABC cannot be classified as an equilateral triangle. The triangle DEF has 2 sides that measure 4 inches, but it has another side that measures 3 inches, so not all of its sides are equal. Therefore, DEF is also not an equilateral triangle. Now let's take a look at this final triangle. Each side of the triangle GHI is 1 meter long. In other words, the 3 sides of the triangle GHI are equal to each other. As I have just said, an equilateral triangle must have 3 equal sides. So the triangle GHI qualifies as an equilateral triangle. The next type of triangle is the isosceles triangle. An isosceles triangle has 2 equal sides. Here's an isosceles triangle ABC. The sides AB and CA of this triangle are both 7 inches, so it has 2 sides that equal to each other. Another example is the triangle DEF you see over here. The sides DE and FD of the triangle DEF measure 2 meters, so their lengths are identical, which makes DEF an isosceles triangle. Now let's try and identify the isosceles triangle among these 3 triangles. Can you do it yourself? Go on and pause the video to try. Or we can do it together. Let's first check the triangle ABC. Its sides are 3 inches, 4 inches, and 5 inches. None of its sides are equal to each other. So ABC is definitely not an isosceles triangle. Let's take a look at the second one, the triangle DEF. Its sides are 8 meters, 9 meters, and 11 meters. Again, there are no sides that are equal to any other side, so DEF is also not an isosceles triangle. The third one, the triangle GHI, has a side that measures 5 feet and 2 sides that each measure 6 feet. Two of its sides, GH and IG, are identical to each other. So GHI is the isosceles triangle we've been looking for. The third type of triangle based on the length of its sides is the scalene triangle. I find this the most interesting one because all of its sides are different from the other two. So, to qualify as a scalene triangle, each side of a triangle must have a different length. Let's take a look at this triangle ABC for example. Its sides are 10 centimeters, 12 centimeters, and 13 centimeters. They are all different. So ABC is not an equilateral or an isosceles triangle, and we can identify it as a scalene triangle. Here is another scalene triangle DEF. As you see, the sides of DEF are 2 feet, 3 feet, and 4 feet. They are all different from each other, so DEF is also a scalene triangle. Now, let's see if we can find the scalene triangle here. The triangle ABC is an equilateral triangle because all 3 of its sides have the same length, that is 3 centimeters. A scalene triangle cannot be an equilateral triangle or an isosceles triangle, so we can be certain that ABC is not a scalene triangle. The triangle DEF has 2 sides that measure 6 inches and one side that measures 1 inch. It has two sides that have the same length, and thus it is an isosceles triangle, which means it is not a scalene triangle. Now let's take a look at this last triangle over here. The triangle GHI has sides that measure 6 feet, 7 feet, and 8 feet. Each one of its sides have a different length, and that fits the definition of a scalene triangle. So GHI is actually a scalene triangle. We finished the types of triangles based on their size, and now it is time to learn the types of triangles based on their angle measures. The first type of triangle in this category is the acute triangle. Now, an acute triangle must have three acute interior angles, and an acute angle is basically an angle that is less than 90 degrees. So, a triangle in which all three interior angles are less than 90 degrees is called an acute triangle. Here is an example. The triangle ABC has interior angles that measure 80 degrees, 70 degrees, and 30 degrees. None of its angles are equal to or more than 90 degrees. So ABC is an acute triangle. Another example is the triangle DEF, which you see on the right. All three of its angles are 60 degrees, which means it is both an acute triangle and an equilateral triangle, because equilateral triangles have 60-degree interior angles. And here is a nice piece of extra information for you. All equilateral triangles are also acute triangles. Now, let's look at these three triangles and try to determine which one is an acute triangle. The first one, the triangle ABC, is not an acute triangle because it has a 110-degree angle. The second one, the triangle DEF, has two 40-degree angles, and we do not know the third angle, so at first look we could mistake it for an acute triangle. But we have a way to find the missing angle. The interior angles of any triangle must add up to 180 degrees. So using this information, we can calculate the third angle as 100 degrees, which is bigger than 90 degrees. So DEF is also not an acute triangle. Now let's check out the triangle GHI over here. Its angles measure 72 degrees, 38 degrees, and 70 degrees respectively, all of which are less than 90 degrees. That means GHI is an acute triangle. The next type of triangle based on the measure of its angles is the right triangle. This type of triangle has one right angle, which is essentially a 90-degree angle. The other two angles of a right triangle must be acute angles because the sum of the interior angles of a triangle always adds up to 180. Here's an example. The triangle ABC has angles that measure 90 degrees, 40 degrees, and 50 degrees. It has one 90-degree angle, so it qualifies as a right triangle. By the way, this little square thing over here is how we show the right triangles. In the second example, the triangle DEF has one 90-degree angle and two 45-degree angles. DEF is also a right triangle based on its angles, but it is also an isosceles triangle because all isosceles triangles have two identical angles. You see, triangles are classified in two ways, one based on the measure of their angles and one based on the length of their sides. Now, let's find the right triangle here. The triangle ABC has one 35-degree and one 55-degree angle. We do not know the third angle, but we can calculate it as we know the sum of the interior angles are always 180. I did the math for you, and it turns out the third angle is actually 90 degrees. There we are. We found the right triangle. It's the triangle ABC. But let us also look at the other two and see why they cannot be right triangles. The triangle DEF has angles that measure 65 degrees, 55 degrees, and 60 degrees. None of its angles is a right angle, so it is certainly not a right triangle. The third triangle, GHI, is tricky. We only know one of its angles, which is 120 degrees. But how can we know if any of the other two angles is a right angle or not. As a matter of fact, it is very easy. We know the interior angles must add up to 180 degrees. So the sum of the two missing angles is 60 degrees. And it is impossible for the triangle GHI to have a 90-degree angle. Therefore, GHI cannot be a right triangle. The last type of triangle we are going to learn is the obtuse triangle. An obtuse triangle must have one obtuse angle, which means an angle greater than 90 degrees. For instance, the triangle ABC you see over here has a 160-degree interior angle, so we can identify it as an obtuse triangle. Let's see the next example. The interior angles of the triangle DEF measure 65 degrees, 20 degrees, and 95 degrees. The angle F is only slightly greater than 90 degrees, but it still qualifies as an obtuse angle, so the triangle DEF is also an obtuse triangle. Can you find the obtuse triangle here? Let's do it together. The interior angles of the triangle ABC are 60 degrees, 30 degrees, and 90 degrees. The angle C is a right angle, but it is not greater than 90 degrees. So the triangle ABC is a right triangle, not an obtuse triangle. Let's check out the triangle DEF. Its interior angles are 70 degrees, 60 degrees, and 50 degrees. All of these angles are less than 90 degrees. So DEF is an acute triangle, and definitely not an obtuse triangle. Let's take a look at this last triangle over here. The triangle GHI has two equal interior angles that measure 40 degrees each, and we do not know the third angle. But we know that the interior angles of any triangle add up to 180 degrees. So let's do the math to find the missing angle. And we find it to be 100 degrees, which is greater than 90 degrees. Therefore, we can conclude that the triangle GHI is the obtuse triangle we've been looking for. And can you tell me the type of triangle GHI is based on the length of its sides? Yes, it is an isosceles triangle, and we know that because it has two identical angles. So that's it. We've reviewed all six types of triangles on the basis of the triangle's sides and angles. If you have watched up to this point, you probably found this video useful, so please make sure you push the like button. And if you want to see more videos like this, consider checking out my channel and subscribing. Have a good day and see you soon.